Convert fractions or mixed numbers to decimals. For example, write 9/10 as a decimal number. So if you notice, we read it as 9/10, and the word tenths is familiar to you because these are your place values that you've encountered when you were still in grade school. So just a quick recall. So we have here the different place values. So after the decimal point, the first digit after it is the tenths place. Next to it is the hundreds. Next to it is thousands. And next to it is 10,000s. Since the given that we have in here is tenths, so that means we can write it as 0.10ths place. So that means that we will write 9 here. So that would be 0.9 or 9/10 because the 9 is in the 10th value. Let's have another example. We have here 300ths. That means that it is in the hundreds place. So you can write 300ths as 0.10ths hundredths. So this is hundreds place. So you write 3 in here and 0 in here. So we have 0.03 or 300ths. But what if we have an example like this? So this time it's already a mixed number. It's so called as mixed number because 3 in here is actually an integer and 2/5 is a fraction. So that means that it is a combination of the two different numbers that we know, the integers and the fractions. So we can perhaps rewrite 3 and 2/5 as 3 plus 2/5 because the whole point of mixed number is combining an integer and a fraction. Now our next concern is how will we write 2/5? Okay. If you try to remember, we don't have 2/5 or fifths as a place value in decimal. So what do we do here? We need to multiply 2 in the numerator and 2 in the denominator. Because what will happen? If you multiply 2 in the numerator, that would be 4. And 5 times 2 in the denominator would give you 10. So if you have 4/10 already, that means we can rewrite 3 plus 4/10 into decimal already. So 4/10 meaning, so again, 4/10 is equal to 0.10 place, so 1 decimal place. So then you put 4 here. And you can have your answer already, which is 0.4, and you just have to change the 0 with 3. So 3.4. Okay, let's try another example. We have here 9/50 and we are asked to write it in decimal number. So this is not a mixed number anymore. And take note, there's no such thing as 50 yet as a place value in decimal. So we need to multiply a number wherein it becomes a multiple of 10. It's either tens, hundreds, thousands, and so on. We just have to make sure that the denominator will turn it that way. In our case here, we multiply it 2 in the numerator and 2 in the denominator. So 9 times 2 is 18. 50 times 2 is 100. So we were able to rewrite 9 over 50 as 18 over hundreds. And we have already hundreds place. So 0 point tenths hundreds. Okay, so this is hundreds place and we have 18, right? So that means we just have to fill in 18. So the answer is 0.18. Okay, now, what if there's no way for us to write the fraction wherein the denominator is a multiple of 10 or hundreds, just like this one? This is a mixed number, so we can write 94 and 1/8 as 94 plus 1/8. But no matter what we do, no matter what number we will multiply to 8, it will not result to 100, a 10, or 1,000. Let's say, for example, 8 times 2 will give you 16. 8 times 3 will give you 24. And so on. That means we don't have a choice but to convert this fraction using long division. So the numerator comes inside and the denominator 8 is outside. So 1 divided by 8, you cannot divide that, so you add another 0, but make sure after or before the 0, after the 0 is being added, you put a decimal point on it. And you align the decimal point, and on top of the 1, put 0. So 10 divided by 8 now is 1. 1 times 8 is 8. Then we subtract 10 minus 8 is 2. Add another 0 and bring down. 20 divided by 8 is 2. 2 times 8 is 16. Subtract, you will get 4. Since you still have a remainder, add another 0 and then bring down. 40 divided by 8 now is 5. Then 5 times 8, 40. And subtract, you get 0. So that means 1/8 is 0.125. So we can replace the 0 with 94 and then 0.125. Now, if in case it happens that your decimal place has its end, or you can count the number of decimal places, we call that one as a terminating decimal. So I repeat, it's so-called as terminating decimal if you can count the number of decimal places. Or in other words, you can identify the last place value. Or it has end. Simple as that. Okay, let's try another one. We have here -7 and 5/9. But similar to our previous example, we cannot rewrite 9 into a certain multiple of tens, or even 100 or 1000, or what, or higher than that, as long as it will not result to a multiple of 10. And at the same time, what is something new now, there is a negative sign in it. Still, this is what we call a mixed number. It's just that -7 is an integer which is negative, and the 5/9 is still a fraction. So nothing changed. The sign goes with 7. Then you add the fraction 5/9. Now we use long division to convert the fraction into decimal by setting up a long division again. So add zero point 0 here, then fill in 0. 50 divided by 9 is 5. 5 times 9 is 45. Then subtract. That would be 50 minus 45 is 5. You still have a remainder. Fill in 0. Bring down 0. 50 divided by 9 is 5. And 5 times 9 is 45. Subtract. That would be 5. Add another 0, you get a 0. Here, because you bring it down. So 50 divided by 9 is still 5. Then 5 times 9, 45. If you notice, the pattern is keep on repeating. So that means no matter how you add zeros and then divide and multiply and subtract, it will repeat itself. That means that it will never end. So we call this one as a type of decimal which is so called as non-terminating. So unlike our previous example, you can count the number of decimal. But when we say non-terminating, it does not stop. And at the same time, it's non-terminating, but there is something that we observe. The 5 is repeated again and again, and there is a pattern in it. That's why it's so called as repeating. So we call this one as non-terminating but repeating decimals. What do you mean by the three dots after the three dots here? We call that one as ellipsis. So again, we call that one as ellipsis. The ellipsis is an indicator that the pattern does not stop, or the decimal place will never stop. It goes on and on. We can also write this, since 5 is the pattern after this, that means after this ellipsis, it's expected that it's really 5, 5, 5, 5, 5, 5, and so on. So we can actually rewrite it as 0.5, and since the 5 is repeated, you can put a line on top of it as an indicator that that's the number that is being repeated. So, going back to our concern in rewriting this mixed number into decimal, it would be -7, that's the integer, 0.555, then you have the ellipsis, or you can write it as -7.5, and there is a bar on top of it as an indicator that it never stops. Okay, that's it.